At the end of the session. Thank you all for staying the entire session. And I'm here to talk to you about analysis of scientific journalism in Nature reveals gender and regional disparities in coverage. So first, let's start off with a little riddle really quick. How is the following possible? A father and son are in a horrible car crash that kills the dad. The son is rushed to the hospital. As he's just about to go under the knife, the surgeon says, "I can't operate. That boy is my son." So let you think for a little bit. And kind of this is supposed to have us think about our underlying biases that we have, particularly with the word surgeon. So if you were stumped a little bit, maybe it's because you have this underlying idea that a surgeon is a man. And also, if you weren't able to solve this, don't worry, most people weren't in this study. And bias is not something that is unknown. Most people know that they have biases. And one field that knows very well that they have biases are journalists. And journalists have found that they too are biased in the way that they get sources, who they cite, who they talk to. But it has been improving over time. So we can see that the percentage of representation of women in news coverage has been increasing over time across most fields of journalism. So what we wanted to know is, are these disparities also reflected in Nature news coverage? So this is like specifically scientific journalism. So there's two main aspects of this analysis. First, gender, what's the ratio of male to female attributed quotes, and then also name origin. So based on a predefined set of name origins of the surname, are there any disparities there? So big caveat, gender and name origins are predictions. They're also binary. So none of this is self-described, which is the gold standard. They're not ground truth. Please forgive me if I omit predicted as I speak. So the data that we look at is basically we take articles and we extract citations, we extract quotes, and from those quotes we attach speakers for who's speaking, and we also extract all names that are mentioned. And from those names, they must include both a first name and a surname. So here's the overview of our analysis. So basically, we take the quoted, the quotes and the quoted speakers and the citations. From the citations, we extract names and we also extract affiliations. In order to predict gender, we take their first name and we predict their gender using a method called genderice.io. To predict the name origin, we use this method previously published by someone else in the lab, which is Wiki 2019 LSTM, and then also to identify regional aspects, which I'm not going to go into in this talk, we use OpenStreetMap. So how do we actually estimate over or underrepresentation? Because just saying a proportion isn't good enough. What we want to know is like, what is this in comparison to an expected background rate? So we assume that the people interviewed in the news articles are active researchers and are publishing papers. Therefore, the demographics that are observed in the news articles should be reflective of the demographics in the research articles. So basically, if you take your Nature magazine, you open it up, the news in the front should be reflective of the research articles and letters that are in the back. And that's kind of our underlying assumption. So here's an overview of all the different types of articles that we downloaded. So we have both the research articles, which are both articles and letters, and then here's all the news. So it's below the teal, are all the different types of news articles. So first, let's look at the gendered quotes analysis. So here's all of the quotes broken down by article, news article type. And then on the right-hand side, we have kind of the proportions over time. So what are we looking at? So along the x-axis, we have the year the article was published, either a research article or a news article. And then along the y-axis, we have the percentage of predicted male either authors or attributed quotes. So here, this kind of faint, small purple line is the proportion of male quotes in news. So we can see that, well, let me describe the other two lines. So these other two lines are the proportion of male first authors or last authors. So we can see overall that we're very far away from parity. So parity is here, this red line. And then beyond this, we can see that quotes in 2005 were predominantly male, even in comparison to authorship rates in Nature. But we do see that this is increasing faster than the rate of authorship in Nature. So that's kind of nice. We're kind of interested what this dip was, and we found that this mostly correlated with the introduction of this article here, which is called Career Feature, and kind of more highlights kind of the day-to-day life of being a scientist. So that can be a good avenue in order to give more representation to people that aren't typically found in Nature News. One small thing that we found that was interesting and is well supported by literature is also that the gender difference in quoting, it doesn't matter who the journalist was. So both male and female journalists both tend to have the same rate of male quotes. So name origin analysis, I'm going to go real quick. So here we have the proportion of quoted speakers by name origin. So here we see that Celtic English, so most quotes come from people with a Celtic English name origin, followed by European, then followed by East Asian. But again, is this more or less than expected? So to try to answer this question, we compare against the proportion predicted Celtic English authors in Nature research articles. And that's what we see here. So again, these kind of grayish lines are what we see by Nature first and last authors. And then this purple line is the quotes that we found in Nature News. So we see that people with Celtic English surnames tend to be quoted way more in Nature News than we'd expect by the authorship rate. We see this opposite trend for people with East Asian surnames. So we see that they're quoted much less than expected. So these are our key findings. We found a bias towards male quotation. We found that the introduction of the career features column helps us reach gender parity. For the name origin analysis, we find an overrepresentation of Celtic English name origins, and we see an underrepresentation of East Asian origin. So there's a bunch of work that I didn't show. We do expand to other sources of science journalism, so we replicated these results in The Guardian. We also include other journals as comparators instead of just Nature research articles, and we also found that these results are consistent. So what can we do? If somebody asks you for an interview, don't be shy, you can interview. Or if you don't want to be interviewed, you can also see who do you recommend to be interviewed. We also have this, if you are interested in also doing your own computational audits, we have kind of a best practices paper. And I'd like to thank everyone in the lab. That's it.
Does anyone have a question?
So I saw some like natural language processing stuff when you talk about the methodologies. Like I saw LSTM, right? So are you worried that these kind of deep learning based natural language processing approaches kind of bias your results in any way? So I saw LSTM, and I recognize that as like this.
Yeah, so basically, this is just as one of the processing steps in order for us to predict the name origin. So basically, they take thremers or like triplets of the entire name, and from that they predict a name origin. How you define name origins is controversial, but we decided on one way, and it was benchmarked against a lot of names that were downloaded from Wikipedia.
Yeah. That makes sense. Thanks.